So I'm just going to point out some similarities and differences. All you really need to be able to do is identify which one is which. This part on the left side of the equal sign is just going to happen. That's just going to happen. You don't really need to memorize this because like the problem is going to be given to you. Does that make sense? You like this will be on your paper. You don't have to make this part up. All you need to do is be able to identify which one's arcsine, which one's arctangent, and which one's arcsecant. Okay, so let's do some similarities and differences. Right off the bat, how can you tell which one's tangent? It has no square root. That's it. Tangent is the one that doesn't have a square root. And then out of the two that do have a square root, how can you tell them apart? I was just a little quiet. I didn't hear you. Yeah, this one has an absolute value of u. Like this one has an extra little doodad out front, and this one doesn't. All right, that's how you can tell the difference. So this one's sine, this one's secant. Now, when you write them out, look, do you see how they're all arcsine, arctangent, arcsecant, u over a plus c, u over a plus c, u over a plus c? They're all the same, okay? These two just have that fraction that's out front. And this one technically has an absolute value there. If you forget that, I don't take off for that because for heaven's sake, okay? But they're all really the same. Let's try a couple of examples. You really just need to be able to identify them. And what makes it harder on the test is like all the problems are all jumbled up. So these are mixed in with the regular u substitution problems. But again, with u substitution, it will have to work out. Like if you can't get it to match, then you just picked the wrong thing. You got to try something else. Like problems like these, if you just keep trying, you'll eventually get it to work. Like here, don't write this down. Let me show you why a regular old u substitution won't work. Let's say you tried to do a u substitution. What would you try and let u equal? Well, like the insides, right? Like the guts of the problem. So you would try to let u equal the 64 minus 9x squared. Like that's what you'd try. But what's that derivative? Like if you did the derivative of this, what would you get? Yeah, negative 18x dx. Well, do you see a negative 18x in there? Well, you could adjust it with a negative 1/18, but you can't fix the variable. There's not an x in there. So like it's simply not going to work. So that if you try it, it's not going to work out. All right, so it's going to be one of these patterns. Which one is this going to be? Sine, tangent, or secant? Sine, good. That's all you have to be able to do is identify it. And if it's multiple choice, if you've decided it's arcsine, you can already narrow down your choices. Do you get what I'm saying? Like if you just even know that, you'll be able to make an educated guess. So we're going to decide what A is and what U is. A is a value. U is a variable. So A is going to just be a number. U is going to take the place of the variable. Now be aware there's all these squareds in there. So A is not 64. A is actually 8. Good. And then U is not 9x squared. It would just be what? It would be 3x. Good. Now, you have to do the same thing you do in a regular u substitution. You have to do that derivative. So what's the derivative of 3x? Be 3 dx. There's not a 3 in the problem, so we're going to adjust with a 1/3. So when you go and plug all of that in, 1/3 goes out front, du goes at the end, or actually you can put it in the numerator. Usually with these patterns, it gets written in the numerator. But you can put a 1 in the numerator and write the du at the end. If that, again, all that comes down to personal preference with where you like to write stuff. And then what's still here is a square root. And the 64 would be what? What can we replace that with? A squared, good. A squared minus u squared. Like I said, that part's just going to happen. Like this part here, it'll just show up in the problem. All you need to do is identify that that's arcsine and write the answer. Oh, I did a copy error. Do you see it? What did I copy wrong? I did a copy error here. Like what should this be? Yeah, that should be 1/3. I'm sorry. I caught it though. All right, so we'll have that 1/3 out front, and you basically just write the answer. It's arcsine u over a plus c. So u over a, that would be 3x over 8 plus c. And what I get oftentimes is people actually don't write this step. And I'm okay with that because you're really just identifying the answer. So if you even skip this step, I'm fine with that. I do want to see this work, but you can kind of just jump to the answer. Again, and I'm not going to write it out this time, but if you tried a U substitution, it would not work. Like when you do the du part, that has to show up in the problem and it just won't. So if you tried it, you would be like, oh, whoops, that's not going to work. So it's going to be one of these three patterns. Which one do you think it is? Sine, tangent, or secant? Secant. Do you see how it's a square root and then you got an extra little doodad out front? So like already, if you know it's arc secant and it's multiple choice, you can like narrow down your choices. Okay. So A is going to be a value. U is going to be a variable. So what do you guys think for A? It's going to just be a number. 3, perfect. And then U, 4x. You still have to do the derivative of that. It's like a regular U substitution. So the derivative would be 4dx. Now we're not going to adjust with a 1/4. Do you see? I threw a 5 in there just to mess with you. So you want to turn the 4 into a 5. So you would actually multiply by 5/4. Because if you multiply by 1/4, it's just going to cancel out. Just throw a 5 in there. I just threw an extra number in there for fun. So when you go to substitute, the 5/4 goes out front. You can put du at the end, but usually it gets put in the numerator for these. Or again, you could put a 1 there and stick the du at the end. And then what we have here is u out front, and then square root u squared minus a squared. Again, if you don't want to write that step, you kind of don't have to, because if you already knew it was arc secant, you're just going to write the answer. Now, there happens to be a 5/4 there, but arc secant also has that 1/a out front. So you just have to put that in there too. So that would be what? Not 3, but 1/3. There we go. And then arc secant, u/a plus c. Secant has that absolute value in it. And again, if you forget to put that, I'm like kind of okay with that. It's whatever. And actually, I think it's only in the answer. I don't think it, oh, okay. You don't need it here. I apologize. I mean, it would be positive, but it's just in the answer. But again, if you don't put that, fine, whatever. It's basically identifying the answer. Made this one a little tougher. You'll all be okay. So what I did with this one is I stuck a variable in the numerator. I kind of messed with it. All right. Do you see how all these patterns, they don't have a variable in the numerator? So it's not going to follow this exactly. The problem is if you do a regular old u substitution, don't write this down. I'll just show you how it won't work. What would you try to let u equal? X squared plus 1. That derivative would be 2x dx. Now you could do a 1/2 to get it down to an x, but what about that minus 5? Like this is a quantity that's all together, so that's simply not going to work. Here's what we're going to do instead. We're going to split it into 2 separate problems. It's like problem A and problem B. I'm going to put this x with the first one and the minus 5 with the second one. So you're going to split this into 2 separate integrals. So this will be the first one. And then we're going to do the -5 for the other one. And you can even put that -5 out front if you want. Like, you know how you can just evict that from the problem? Actually, let's do that. Can we do that? Like just put the -5 out front. I feel like that's nicer if you can just kick it out. Put a 1 there. Or you could even put the dx in the numerator. Again, this all comes down to personal preference. So here's what's going to happen. This one will now work. It will be a regular old U substitution like we did last class. It will just work. This one, I got rid of the variable in the numerator. Now it's going to be one of these patterns. So which one of these three is this one going to follow? Tangent, because there's no square root. Okay, so we're just going to do it as a problem A and a problem B. So for this one, we're going to let u equal to x squared plus 1. Now it's going to work. Derivative is 2x dx. And then what will we adjust that with? 1/2, perfect. So when you go to substitute in, the 1/2 will go out front, du will go at the end. What's still there? I didn't get out my highlighter, I'm sorry, but what is still there that we like didn't take care of already? We substituted in for x dx. So that part's taken care of. But I don't want to write x squared plus 1, I want to write u. And it's not u, it is 1 over u. Good. So what's that antiderivative? ln, good. It's 1/2 ln of u, which is x squared plus 1. And then it would be plus c, but I still have to do the other half of the problem. Okay, so for this one, a is a value, u is a variable. So what is a going to be? And it's almost kind of tricky for this one. Yeah, 1. And u is just x, which is actually kind of nice because that means du is dx. There's no adjustment that has to happen there. So we've got -5, 1 over, integral 1 over u squared plus a squared. And you can put the du in the numerator, or you can put it off to the side. Again, that doesn't matter. If you like to skip this step, that's okay. As long as you know it's arctangent, you can jump straight to the answer. And I'm going to kind of string this all along for like one whole answer here. So it'll be -5 times, now arctangent had that 1 over a out front. So that would be, oh, actually, what would that be though in this case? That 1 over a? It'd be 1 over 1, which just is 1. So actually, we don't end up with that there. I mean, it's there, it's just 1. Arctangent, u over a plus c. So what is u over a going to be for this one? Yeah, good. It'll just be x, right? Because x over 1 would just be x. And then slap a plus c at the end of the whole thing. So you split it into 2 separate problems. We'll just try one more of these and then we'll do a break. What did I change about this one? Like, what did I put in this one that wasn't in the other ones? Yeah, I put boundaries in it. Oh, I'm sorry. I can go back and pause. All right, so I stuck boundaries in this one. I'm going to pause the recording. I want you guys to try and do the antiderivative, which it's going to be arc what? Which one is this? Tangent. Okay, so you already know there's going to be an arc tangent. Don't put a plus c, put like such that 0 to 2, and then we'll go over plugging those in together because I know that part's tough. What'd you put for a? 2, good. And what'd you put for u? X, which is awesome because du is dx. So if you recognize that it's going to be arctangent, you can skip that middle step and just go ahead and write out the answer. What's going to go out front? 1 over 2, arctangent of u over a, so x over 2. Don't put plus c, instead it's such that 0 to 2. That's as far as I asked you to go. Did that go okay? Okay, we're going to do upper boundary minus lower boundary. Write that out blank. That helps so much with not messing up your negative signs. Just like set up the blank parentheses. So upper boundary, if we plug in 2, 2 over 2 would just be 1. So 1/2 arctangent of 1. And then if you plug in 0, 0 divided by anything is just going to be 0. So 1/2 arctangent of 0. If it's free response, you get to stop. You don't have to evaluate that any further than that. But if it's multiple choice, you will have to keep going. So it's worth having the conversation. Arc trig functions, it's backwards. It's an inverse. It's an inverse trig function. Do you remember how you can also write it like this with the little -1? Okay, it's inverse. So it means you have the answer you're looking for the question. It's like you have the sides of the triangle. You're looking for the angle. So think about your unit circle. To end up with 1, these need to be the same. Tangent is y over x, or opposite. Remember SOHCAHTOA, opposite over adjacent. What do these have to be in order to end up with 1? Good. Well, you jumped straight to the answer. Pi over 4. What are the sides, though? You like kind of skipped that stuff. Good. Anything over itself is what gives you 1. So this will be 1/2 times pi over 4. Again, you're looking for the angle. The thing with pi in it is now your answer. Because usually you do tangent of pi over 4 and get 1. But arctangent of 1 gives you pi over 4. We're just reversing that. All right, minus. Now 0 is going to be right here. Again, tangent is y over x. 0 over 1 gives you 0. What is this amount of rotation? Like, how much pi did you go if you're right there? Yeah, like that's nothing pi. I always put pi with the 0. You can just put 0, but I always put 0 pi just to like remind us that it is actually a rotation. It's just you didn't rotate. You didn't go anywhere. A lot of people will just memorize tangent of 0 is 0. Do you know what I'm saying? Like a lot of people will just end up remembering that one. What number am I on? 5. So if you tried to do a u substitution, it would not work. If you let u equal this, your derivative would be 2x minus 10. There's not a 2x minus 10 in the problem. Also, the way it's written right now, it doesn't follow any of these patterns. So it's kind of like back to the drawing board, and this is another method you can use to get through the problem. So we're going to complete the square. You want to take 10, divide it by 2, and square it. So what would that give us? 25. Give it a hug. Now you need to turn the 25 back into a 34. You're not allowed to just change the problem. So what do you have to tack on at the end? Plus 9. And then dx. That is literally what we just did here. I just threw an integral symbol at the front and a dx at the end. All right. And then how would you rewrite that? It's going to be something squared minus 9. What would be like the something that goes in there? X minus 5. I love completing the square. It's such like a good pattern. Like if you can follow a pattern, it's so good. Now this follows. Oh, did I do a copy error? Minus 9. Oh, plus 9. Thank you. Now this follows one of these. Which one does it follow? Tangent. There's no square root. What is A? A is going to be a number. 3, good. U is going to take the place of the variable. That would be the x minus 5. And if you do the derivative of x minus 5, it would just be, 1 dx. The minus 5 we don't worry about because that's a constant. You do the derivative, it's gone. Now you can write out the middle step if you want, but you guys already told me it's arctangent. So just write it out. What goes in front of the arctangent? So 1 over 3, you're basically just writing the answer at this point. 1 over 3 arctangent u over a, so it would be this over 3 plus c. That's all that there is to that. It's pattern finding. And basically, if you can complete the square, you're fine. We're just going to try one more of those. And again, in like a multiple choice situation, and on the AP exam, like it's timed, so you have to go as quick as you can. If you come back to something like this and you just have to like make a guess, I would hope you'd be like, oh, there's a square root. It's either sine or secant, but there's not anything in front of this, so it would have to be, which one? It has to be sine. Pick an answer with an arc sine in it. Do you get what I'm saying? Like if you didn't, basically, I should not have this on the recording, but basically saying if you didn't want to do the problem and you had to just make a guess, it would pick something with an arc sine. Okay. So we're going to need to take out that negative first. It's going to be just like that one that I did up there. So it'll be x squared plus 4x, and then you divide by 2 and square. Now 4 is kind of weird with completing the square, because if you divide by 2 and square, you get 4. That happens because 2 plus 2 is 4 and 2 times 2 is 4. But it's not really a 4, it's really a negative 4. Because if you distributed that negative through there, you'd have negative 4. So you have to turn a negative 4 back into a positive 5. So plus 9. And then the whole point is that you can write it as something squared. And so what would be the something that goes in there? X plus 2. Now, if you want to, oh, and dx, I don't need to get punched. All right, if you want to rewrite it the other way around, and you can if you want to, I'll just do this for the sake of being really thorough. It would be 9 minus the x plus 2 squared. If you can see that, you don't have to write that. If I'm just showing it to you. And that's why it follows your arc sine pattern. So what would be A for this? 3, good. U would be x plus 2. And so du would be dx. Hello. Thank you. And we already said it's arc sine, so you can kind of just write the answer. Now, arc sine does not have that little fraction out front, so just don't put that. It'll just be arc sine of what? Yeah, u over a, so x plus 2 over 3 plus c. So sometimes you have to complete the square in order to make it work. Okay, it's just divide by 2 and square. The last method, bless you, I know you're like, when will it end? The last method is your synthetic division. I'm a little bit more nervous about that one because if you didn't remember completing the square, you're probably not going to remember synthetic division. Let me pause the video and do an example of one of those before I jump to the problem.
You don't remember?
Really? I remember that. I do not remember the completing square at all. Mr. Almanac would that?
Oh, all right. What would go in the little box off to the side for this one? Yeah, -3. It's basically like a side problem. Is the countdown in order?
No.
No. What's missing? X. So it'll be 2, 4, no x's, -5. You guys go ahead and divide that out. Multiply, add, multiply, add, multiply, add. Okay. Okay. That's easy to fix. Easy to fix. Well, no, I think you did 18 minus 5. Like, yeah, that happens. Okay, so when you go to put that back in the problem, again, you're just going to have an integral symbol out front and a dx at the end. It's exactly what we just did right there, but you're going to make it calculus, okay? So it'll be 2x squared, good, minus 2x plus 6, and then we're going to have minus 23 over the x plus 3. And then you're going to do the antiderivative. So for this first term, I always cover up the coefficient. It would be 1/3 x cubed, but there's a 2 there. So it'll be 2/3 x cubed minus, and then what's the next term gonna be? Antiderivative of 2x. Good, x squared plus 6x minus, okay. Pretend this isn't here for a second. Actually, pretend the 23 is not there either. Pretend it's 1 over x, because all these are just like constants. They're not going to matter. What's your antiderivative for 1 over x? ln, okay? You're just going to have a 23 in front of the ln. And instead of just x, it's going to be x plus 3. But it's like, because the constants don't matter, right? So it's minus 23 ln, absolute value x plus 3 plus c. It is. We're going to do one more. You're going to be okay. I don't want to just do one. Well, I'll put boundaries on this one too.
Is this our last problem?
Yeah, last one. I have like a gajillion examples and I kind of just look at them and pick and choose which ones we're going to do. I fit this onto one piece of paper too. Go us. The reason we're doing synthetic division, if you're like, why on earth are we doing this? How else would you do that antiderivative? Like, can you think of another method? Like, there's nothing that's going to work, right? Like a U substitution is not going to work. It doesn't follow those inverse trig patterns. You have to divide it out. So what number will go in the little box over here? 1. Is the countdown in order? Yes. So it'll be 1, -3, 5, -3, and then go ahead and divide it out. Did you get 0? It's always cool when the remainder is 0. All right, so we're going to put that back in the problem. If you mess something up, it is probably a negative sign. Like I would bet real money.
Yeah, it was.
It just always is. The problem, okay, so I do like these problems. The issue with them though is if you make a mistake on like this column, do you know what I'm saying? Like it cascades through the rest of the columns and sometimes your numbers can get completely out of control if you make a negative sign issue. All right, so it'll be 1x squared minus 2x plus 3 dx. And then isn't that a way easier problem now? Okay, antiderivative. This is your fundamental theorem of calculus. Antiderivative would be 1/3 x cubed minus x squared plus 3x such that 1 to 2. And let's review. Derivative means, antiderivative means, yeah. When we get a numeric answer, what that indicates is that's the area under the graph. Like if I made you draw this, that would be the area that's underneath, right? Upper boundary minus lower boundary. So if we plug in 2 cubed is 8, that'll be 8/3. Minus 2 squared is 4, plus 6. And then if you plug in 1, that'll be 1/3 minus 1 plus 3. I will let us stop with that, but if I forced you to go through the rest of the way, like in a multiple choice situation, could you fight through that? Like, you would have to be able to, okay?